We're now going to practice just a few more single replacement reactions. So let's look at this first one I've written here on the board. First, we have magnesium plus potassium chloride. This is a single replacement reaction because you have an element plus a compound. We want to see if magnesium, which likes to be a cation, will be able to replace the thing that's a cation over here. So what we're going to do is we're going to look at our chart. We need magnesium to be higher than potassium on the activity series. We're going to look for magnesium and we're going to look for potassium. If you look here, magnesium is right here and potassium is right here. Potassium has more activity than magnesium. So magnesium is not strong enough because it's below potassium, not strong enough to be able to kick out potassium. So this is a no reaction. No reaction occurs because magnesium is less active than potassium. Okay, let's look at silver plus hydrochloric acid. So silver wants to replace hydrogen. Again, silver needs to be higher than hydrogen in the activity series. Silver is all the way down here at the bottom, and hydrogen is right here. Hydrogen is higher than silver. So this one as well is a no reaction. Now we're going to look at this one. Iodine normally likes to be an anion. This guy likes to be an anion. So those are the two that are trying to be replaced. So for this, for our halogens, we look at our activity series just right off of our periodic table. The less you weigh, the more reactive you are. So if you look here, fluorine is here and iodine is here. Fluorine is here. I know there's a bit of a glare there. Let me look over here. Fluorine is here and iodine is there. So fluorine can kick out iodine, but iodine cannot kick out fluorine. So iodine is trying to kick out fluorine. This is also a no reaction. Now let's look at zinc trying to kick out lithium. Zinc needs to be higher than lithium on the activity series. Zinc needs to be higher than lithium on the activity series. Zinc is here and lithium is there. Zinc is here, lithium is there. So zinc is not active enough or reactive enough for this reaction to happen as written. Okay, last one. Calcium trying to replace lead. Calcium is here. Lead is here. Calcium is higher than lead on the activity series, so this reaction does occur. So let's write it out. Calcium is going to replace lead. So you're going to end up with a Pb lead. So that's going to get kicked out. Now we're going to combine calcium, which is a 2+, and oxygen, which is a 2-. When we balance our charges or crisscross and reduce, we get CaO. So those are some examples of single replacement reaction. Next, we're going to do a set of examples where everything is mixed in together. Okay, here we're going to identify the reaction types. We're not having to predict the products. We're just saying what these reaction types. And it's just so you get used to kind of recognizing them. So number one, well, why don't you pause the video right now and see if you can identify them all. Then you can come back and you can see what the answers are. Okay, for the first one, S plus O2, you have two reactants. Those are two elements going to one product. Remember, if you have one product, that is a combination or a synthesis reaction. Okay, number two, calcium chloride plus sodium phosphate. Calcium chloride plus sodium phosphate. Now we have calcium phosphate plus sodium chloride. This is compound plus compound to give you compound plus compound. And if you notice, your cations are switching places. This is a double replacement reaction. Number three is like number one, two things coming to make one product. One product is a combination reaction. K plus Cl2 to give you KCl. Potassium plus chlorine to give you potassium chloride. Okay, here we have hydrogen peroxide, H2O2, one reactant, and it's getting broken up into water and oxygen. This is a decomposition reaction. One reactant getting broken down into two or more products. Okay, Na plus H2O to give you NaOH plus H2. So this is an element plus a compound, give you a compound plus an element. If you remember, I told you in the last slide, anytime you see water, you should rewrite it as an HOH. Still water, two hydrogens and one oxygen, but we've written it different, HOH. So what you see here is sodium kicking out the hydrogen. So you're left with an OH, the hydrogen out of water. So you're left with an OH, and that combines with sodium, and you're left with the hydrogen as a diatomic. Single replacement reaction. Number 6, potassium chlorate. One reactant, multiple products. One reactant, multiple products. This is a decomposition reaction. Number 7, this is a hydrocarbon. Hydrocarbon plus oxygen. Anytime you see a hydrocarbon plus oxygen, that is a combustion reaction, and you're going to make CO2 plus water. This should say CO2. I apologize. Okay, potassium iodide plus chlorine. Compound plus element. Give you compound plus element. Single replacement again. Chlorine kicks out iodine. Hydrocarbon plus oxygen to give you CO2 plus water. That is combustion. N2 plus H2 to give you ammonia. Ammonia is a single product. This is combination or synthesis. P plus O2. Even though this is O2, we call this a synthesis reaction because we end up with one product. One product. And the last one reactant, iron 3 hydroxide, to give you iron 3 oxide and water. This is a decomposition reaction.